What's up, scholars? Today we're going to define what a function is and talk about the domain and range of a function. So here we are at our table of contents. We're on week 2. And today is Monday. Functions, definition, and domain, and range. This may be on your page 13, maybe a little bit later. Doesn't matter, whatever page it is. Functions. And here we go with the definition. A function from a set D to a set R is a rule that assigns to every element in D a unique element in R. So we have a function here, and it goes from D to R. And it's just a rule that every single element in D goes to a unique element in R. That word unique is very important, meaning only one. It can only go to one. So every element in D must go to a unique element in R. There are 3 ways that you can determine whether or not some kind of relationship is a function. So you can do it graphically. You can do it by mapping. You can look at the points. So let's look at a graph, right? So if I have a graph that you know very well, which is the function y equals x squared, there is a test that you can do. And this test always works. It is called the vertical line test. So basically all you do is you look at your graph, and if you can drop a vertical line down anywhere and it only hits one point, then it's a function. So here I can drop a vertical line down, here I can drop a vertical line down, anywhere I can drop a vertical line down, and it's only going to hit one point. That is our unique element in D. So this is kind of like our D here. It maps to only one point in R up here. So right here, it starts to come up pretty high, right? The slope gets really steep, but still, even if I drop a vertical line down, even as steep as it's going to get, it's still always only going to hit one point on this graph. So therefore, that is a function. Yes. What if I swap it and I turn it on its side? Like this. Here, if I do the vertical line test, I drop a vertical line down, it hits in 2 different spots. And so that's not giving me a unique element popping out in R. There's 2 of them for 1 input. I'm getting 2 outputs. So that is not a function. Not a function. And there's a yes. Not a function. So let's see. Another example. What's another one that you know the equation x cubed, cubic function? Again, this looks like it's getting really steep, but no matter where I drop that line down, it's only going to hit 1 point. So for every element in D, I only have one unique output in R. So yes, this is a function. And one more, a really popular one to test students with is the circle. So again, if I drop a vertical line down in this one almost anywhere, I'm going to hit 2 points no matter where I drop that line down. Well, almost anywhere. So this is not a function. Not a function. All right. Another way to view this input output, making sure that for every input you only have one output. Another way to do it is by mapping. And they kind of draw like these bubbles here, right? Maybe my bubble over here is a little jagged, like these little ponds or whatnot. And so you have like your X, your input, and then your output, also known as D for domain. We're going to talk about that in a bit. And R for range. And then they have these points that they map. And these points map to other points. And so this is like your x1, x2, x3, x4, y sub 1, y sub 2, y sub 3, y sub 4. And this x1 just goes to this point here. This one goes to this point here in the range. This one goes to this, and that one goes to that point. So the question is that a function? And in this case, you'll see that you can always think about this as if it were on a graph. If I were to put this x value wherever it is, I don't know where it is, we'll just say it's here, and it's at this y value. And then this other x value somewhere else along the x-axis, I don't know, before or after it, doesn't matter. It's going to the same y value. So if I plot that, if I plot those two things, they just kind of make like a little line right there. And that's okay, because I could drop a vertical line down between those 2 points, and it's still only going to hit once. So the x values going to one y value, that's okay. That's a function. Let's look at another example where it would not work out. Maybe you're already thinking about flipping this around and making it the case where it doesn't work. So here's my x, here's my y. This is gonna be heart, star, smiley, heart, star, smiley. And in this case, I'm going to have it to where heart goes to heart, and then also star, heart also goes to star, this star, and then just smiley goes to smiley. That's fine. In this case, this is going to be not a function. Not a function. Why is that not a function? Well, if I look at this point here with heart and star, if I go to the x-axis and I plot my heart is here. And then I come up on the y, it hits where y is heart, and it hits where y is star. So I have these 2 points, and they're right on top of each other on the y-axis. So therefore, if I drop a vertical line down between those two, I'm gonna hit both of those points. So you have an example of where it's okay if these 2 points map to 1 point on the y-axis, that's okay. But if 2 points on the y map to 1 on the x, that's not okay. That is not a function. It is not okay. So this is what you're looking for when you're looking at mappings, is two y values that go to one x. This is not a function. And then the last way to look at it is like, let's look at two pairs of points. All right. Set of points. So again, I have my x and I have my y. And my x is going to be -1, 0, 1, and 2. And my y is going to be 3, 4, 3, 6. Something like this. It doesn't matter how exactly all of those graph on the graph. What we're looking for is we're always looking for repeats to see if something is going to pass the vertical line test or not pass the vertical line test. So I'm just going to put up another example here. So one of these two is a function and one of them is not a function. So we're going to look over here and see if there are any repeats. So there certainly are. I have this point here at -1, 3, and I have this point here at 1, 3. So if I just kind of think about that on the graph a little bit, which that's how I always default because I'm always. So if I go to -1, 3 and 1, 3, I'm okay there because again, I'm making this like line between these 2 points. I can always drop a vertical line down and no matter where I do, I'm only going to hit this once. So this one is okay. This one is a function. This other one, let's find the repeats here. I have 0, 9 and I have 0 and 11. If I graph those points on the graph, when x is 0, I'm at 9 on the y-axis, and then when x is 0, I'm at 11 on the y-axis. So those 2 points are graphing right on top of each other. That's not going to pass the vertical line test. You can see the y-axis is a vertical line just coming right straight down through those 2 points. So this is going to be not a function. So when you're looking to see if something is a function or not, you're always going to be coming back to the definition, right? And that is for every element in D, for every element like in your domain, for all of your X values, all of your inputs, you want one unique element to be your output in R, in the Y-axis.